Okay, now we're going to do some calculation with scientific notation. Okay, this is example 4, astronomy on page 371 in our textbook. Okay, so I would like to have a volunteer to read this whole paragraph to the whole class.
The galaxy in which we live is called the Milky Way. It has a diameter of approximately 100,000 light years. A light year is the distance light travels in a vacuum in 1 year, 9.46 times 10 to the 15th power meters. Find the diameter of the Milky Way in meters.
Okay, thank you. Okay, all right. So, okay, that was very good. Okay. So this one here says that this one here says that the Milky Way, okay, the galaxy we live is called the Milky Way. Okay, it has a diameter of approximately 100,000 light years. Okay, so let me draw the picture. Okay, a picture is better than 1,000 years. Okay, so I will have this Milky Way. We'll have from here, let's say to here. Okay, and the diameter. Okay, so it is 100,000 light years. So 9 years, it is the distance that the light travel in a vacuum in 1 year. So if you travel from one end of this Milky Way to the other end of this Milky Way over here, it's going to take you 100,000 years to travel when you travel in the speed of light. So when we think about this, we are so small. All right, so, okay. Now, over here, they ask you to represent this diameter here in meter instead of this unit 9 year. So how can we convert this 9 year here in meters? Okay. So it was given, what was given? So it was given 1 9 year is 9.46 times 10 to the 15 meter. Okay. So what should I do with this numbers?
Put it in scientific notation.
Yes, you got it. So let's put them in scientific notation. Let's put them in scientific notation. This 100,000 light year, that is going to be 1 times 10 to the watt power.
Fifth,
right? You go 5 places to move it from decimal point from here all the way to here, right? So 10 to the 5th. Unit over here is 9 year. Okay, so the unit here, it is 9 year. Okay, now to convert that in meter, we do the unit conversion, right? So we times it, right? So it is 9.46, and here times 10 to the 15, and this is in meters. Remember, this is for 1 9 year, right? So we're given 1 9 year is 9.46 times 10 to the 15 meter. So to convert those into meters, we can do the unit conversion. So we times 9.46 times 10 to the 15 meters, and then per 9 year, okay? Now over here, then this will cancel, right? Okay, and then we can convert that into meter, okay? All right, so basically you just use this number to times this to convert that into meter, okay? Okay, now to do that, that is equal to, you multiply this number, 1 times 9.46, so that is 9.46. So 9.46 times 10 to the what power. So we have this exponent over here, it is 5, right? So you have 5, and then you're adding the 15. So add this 15. Yeah, you got it. It's 20. This is 15, so this is 20. Okay, so that is equal to 9.46 times 10 to the 20, and now it's in meters. Okay, so the Milky Way, the diameter will be this number. Okay, 100,000 light years. Okay, all right. Example 5. Okay, example 5 over here. Let's talk about the world oil reserve. Okay, according to estimates in the World Fact book, there were, this number over here, it is, how do you read this? 1,000, million, billion, trillion. This is trillion, okay? So 1,350 billion, okay, barrels of crude oil reserve in the ground at the start of 2010, okay? So it's about 10 years ago, okay? At that time, the world demand was 31 billion 200 million barrels per year, okay, according to the Energy Information Administration. Okay, if annual demand as of 2010 remains the same, and if no new oil discoveries are made, when will the world's oil supply run out? Okay, so let's find out. Okay, let's organize information. Okay, so what do we know? So we have this word. Okay, so this is right. So this is how much we have. And then what happened over here, it is, so the demand per year, okay? So that's how much we spend, how much we use every year, okay? So it was this number, okay? So that's how much we use every year, how much we spend every year, okay? So we want to find out, well, if this is all we have, okay, no new oil discovery are made, okay, that's all we have, okay, and then you spend this much every year. When will we run out of oil, right? Okay, that'll be interesting to find out. Let's find out. Okay, all right. So how can we find out? Think about the money that you have. Say this is how much money you have, and you spend this much every year. That's all the money you have, and then you don't earn any new money, and then you spend this much every year. Then what should we do with this two number?
Divide.
Okay, yeah, some people say subtract, some people say divide. Okay, think about your saving, right? For example, okay, let me give you another. So suppose you have $5,000 saving, and then every month you spend 2,500. Then and you don't earn any new money, right? Then after 2 months, you're gonna run out of money, right? So what do you do over here? You divide, okay? So you're gonna divide this two number. That's how much you have, and then every month you spend this much, okay? Every year you spend this much, then you're gonna divide them to find out the number of year that you're gonna run out, right? Okay, so we're gonna divide, okay? But first, let's start with let's write both of them in scientific notation, okay? It is 1.3 1.35 times 10 to the what power?
12.
Yes, 12. 12 power. Okay, 12. Okay, that's good. So this is how many barrels that we have. Okay, and then we divide. Okay, So I'm going to divide by this number. This is how much we spend every year. Okay. So write this in scientific notation. So that will be what? 3.12 times 10 to the what power?
9.
9. Let's count again. Okay, let's count again. So 3, 6, 9. But then you have to move all the way to here.
Yeah,
so
to
you
10.
got, yeah, 10, right? So 10. Okay, the 10 power right here. Okay, all right. So now we're going to do the calculation using this scientific notation. Okay, so we're going to do this part right here. So this is going to have this part right here. This part over here, we calculate. Okay, get your calculator. Okay, and tell me this divide is about what? 1.35 divided by 3.12.
0.4326923.
Is it 43?
Yeah, 0.43.
Something, right? Okay, let's just keep 2 decimal point right now, okay? Because we want the number here, okay? Let's keep 2 decimal point for now, okay? So this, okay? So this is this. Okay, so we got this. Now this part over here, okay? This part over here. Okay, so the 10 to the 12 power divided by 10 to the 10 power. Remember when they're the same base and they divide, what do you do with the exponent over here?
Subtraction.
Subtract exponent. Yes, you got it. So times 10 to the what power?
Second.
Second, right? Oh, 12 subtracting 10, that's 2. So that will be the second exponent over here. So we got this. Okay. Now, let's write it in standard notation. So times 10 to second power, well, 10 is, so you're going to have this decimal point move left or right? Move this decimal point to,
Right.
to the right, 2 places, right? So you're going to get, what number do you get?
43.
43, right? 43, you're going to move it 2 places, right? To the right, 2 places. So you get 43. So that's equal to 43. So 43 years. This is 43 year from year 2010. What year is that?
2053.
Yeah, 2053. And then the word crude oil reserve will run out. Isn't it kind of scary? In 2053, if no new discovery and we keep on spending this much every year, then the oil reserve will run out. Isn't that scary? I used to have talk about this in class, and students say, "Is it true? Is it really?" Yeah. No one. Okay, well, it's kind of scary. Without oil, then you can't drive your car and all those things, right? Okay. I think we're still here, right? Are we still here? We should be. Hopefully, we're still here. Okay. So 2053, isn't it? So yeah, kind of scary. So we need to discover new energy. Okay. So yeah, we need to use renewable energy. Okay, not just using oil. Okay. So we never know. You know, who knows? In 2020, we're in this pandemic, right? 1 year before that, we didn't know. You know. Yeah. Okay. So we need to find a new solution. Okay. Okay, this one over here. This is the last one. Okay. Now, how can we calculate this? Well, you can keep on punching the zero on your calculator, but a better way to write this, it is convert all of them into scientific notation first. Okay. So that's first. So first we convert each to scientific. Okay. Now let's convert this one. In scientific notation, what would this be?
6.4.
6.4 times 10 to the
Fifth
should
power.
put positive, negative?
Negative.
Yeah, it's negative. Negative fifth power. Okay. A tiny number, right? Okay. So what about the second one? This is what? In scientific notation. So that will be 2.4
2.4 times 10 to the 1.
7.
10 to the 7. Yeah. The 3, 6, and then one more. So 7. Okay. So 7. Okay. Then here it is 4 times 10 to the, this one you move 3 and then another 2. So that's 5.
Mhm.
10 to the 5th power. This one, oh, the last one here, it is a tiny number, 1.2 times 10 to the, so we have a negative exponent. And you move how many places? 3 and then another 3. So that is 6, make it 6. 6. Okay. Now after that, you put the part that, you know, for scientific notation, those number, there's not a power of 10, you put them together. So because multiplying, right? 6.4 you times 2.4 and then divide by 4 times 1.2. Okay. And then this part over here will have those power of 10 together. So 10 to the negative 5 times 10 to the 7. Here it is 10 to the 5th. And 10 to the negative 6. Okay. So what I have done over here, you put this part, those are not power of 10. Okay. So because multiplication is commutative. Okay. So you put them together. So 6.4 times 2.4 and then divide by 4 times 1.2. That's the first part. And then this part here, you have those power of 10. Okay. Over here. Okay. Now do the calculation. Then this part over here is going to turn on. So that is going to turn out to be 3.2. So we have 3.2. And then this part over here, okay, let's think about this. So first we can simplify this numerator on top, right? So remember when they multiply, they have the same base. You keep the base and you add the exponent. So negative 5 adding 7 will be what?
2.
2.
2. Good. Okay. Now the denominator here, you also add the exponent, right? So 10 to the what power?
Negative 1.
Negative 1 power. Now because it's dividing, okay, when you divide, what do you do with the exponent?
Subtract.
You subtract the exponent, right? So that's equal to 10 to the, okay, 10 to the what power?
First.
Third power, yes, you got it, okay? Because there's 2 subtracting the negative 1, then you get positive 3, right? 2 subtract negative 1 give you positive 3. So 10 to the third power. So this will be 10 to the third power over here. Okay, so in scientific notation. Okay. All right. So this is all the in scientific notation. That's good. Okay.